Hi, hello, welcome back to the Math Club, Matthew, where you'll get content based on math for class 9th and 10th. In our previous video, we discussed about HCF, LCM, and the relation between them, and some very important questions based on those topics. If you have not watched that video, please check it on our YouTube channel. In today's video, we'll be discussing about irrational numbers and the proof of irrationality of numbers. So, in the last video, we discussed about fundamental theorem of arithmetics, prime factorization, HCF, LCM and their relationships. In this class, in this video, we'll be discussing about irrational numbers and their properties. So, irrational numbers are those numbers which cannot be written in the form of p by q, where p and q are integers and q is not equals to 0. So, we know that rational numbers are those numbers which are written in the form of p by q, where p and q are integers and q is not equals to 0. But irrational numbers are those numbers which cannot be written in the form of p by q. So they are just opposite of rational numbers. In other terms, we can say those numbers which are not at all rational, they are not at all rational, are called as irrational numbers. They are represented by the symbol q dash. We represent the symbol for rational numbers by the letter q, whereas for the irrational numbers we represent by the symbol q dash. So there is no relation between rational and irrational. Those numbers which are not at all belonging to the set of rational numbers belong to the set of irrational numbers. So for example, if you take example, we'll take square root of all the non-perfect square numbers such as 10 or square root of 24, etc. We know perfect square numbers. Which are the perfect square numbers? Like 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, etc. So except these numbers, the square root of other numbers like square root of 15 or square root of 17 or square root of 8, all these numbers are irrational numbers. So from this you will get certain numbers, like you will have to prove all such kind of numbers are irrational. So now let us discuss how to prove these numbers are irrational. Before going into the proof of proving certain numbers are irrational, we have to study one more theorem which says if p divides a square, then p also divides a, where p is a prime number and a be any integer. So this says if p divides a square, then p also divides a. Let me demonstrate it with a simple example. I'll take the number 10. I'll take the number 10, a to be 10. Then the value of a square will be 100. So let me take any one of the factor of 100. For example, let me prime factorize 100 for that. 2, 5 50s are 2, 25s are 5, 5s are 5, 1s are. So I can write 100 as 2 into 2 into 5 into 5, 2 into 2 into 5 into 5. So now let me prime factorize 10 in the similar way. So 10 can be written as 2 5s are 5 1s are. So 10 can be written as 2 into 5. Now look here, if you look at the factors of 100, prime factors of 100, 2 and 5 are the two prime factors that we will find for 100. You can observe that 2 and 5 are also the factors of 10. So here 2 is a factor of 100 in the sense 2 divides 100. That is, if you divide 100 by 2, you will get an integer as an answer. So if 2 is dividing 100, that is a square, then 2 also divides a. That is, if you divide 10 by 2, you will get the number 5. Similarly, here we have one more factor for 500, that is 5. So if you divide 100 by 5, you will get the number 20. So you got to know 5 divides 100. So when you divide 100 by 5, you will get an integer as an answer. So 5 divides 100, that is 5 divides a square. So here you can also see, if you divide 10 by 5, you will again get the number 2 as integer as an answer. So 5 divides 10 also, 5 divides a also. So here the value of our p are the integral, the prime factors of those numbers which we are taking over here. So if this p divides a square, then p also divides a. This is what the statement says. This holds true for every integer. This holds true for every integer that you see. You can check it for other numbers also. Check it for a few numbers and come back. Now then we'll discuss how to prove a certain number is irrational. Now let us see how we can prove a certain number is irrational. For this we will be using the method of contradiction. We will be using the contradiction method. In this contradiction method, we will first assume the negation of our statement, that is, we have to prove that root 2 is irrational. So initially in our proof, we will assume that root 2 is rational, and then by one we will come to a conclusion that root 2 is irrational. Let us see how it is happening. So first let's assume that root 2 is a rational number. Let's assume root 2 is rational. We all know that all the rational numbers can be written in the form of p by q, where p and q are integers and q is not equal to 0. So we are also going to write root 2 in the form of p by q, where p and q are co-primes. What do you mean by co-primes now? Sir, we all know that rational numbers are written in the form of p by q, where p and q are integers and q is not equal to 0. Then why are you taking the risk of taking it as co-primes? I'll tell you the concept of co-priming before. Here co-primes means any two numbers which does not have any other factor in common other than the number 1. For example, if you are considering two numbers, the number 5, I'll take the number 18. We can write the number 5 as 1 multiplied by 5. On the other hand, we can write the number 18 as 1 multiplied by 2 multiplied by 3 multiplied by 3. Now compare the factors of these two numbers. Does these numbers have any number in common, any factor in common other than the number 1? No, we don't have any other common factor for these two numbers other than the number 1. So in such cases, we call these two numbers as co-primes. We call such numbers as co-primes. Saying in simple words, co-primes are any two numbers having no other number in common other than the number 1. So we call them as co-primes. So here, what is the need of writing co-prime as? Okay, I'll tell you an example. 0.5 can be written in the form of p by q as 5 by 10. This is the way in which we express a rational number. But this way of expression is not at all unique. We can also express it as 5 ones are 5 twos are, that is 1 by 2. You all know that is this method is called as method of simplification. So here we are going to take p and q in the simplest form. If you look at 5 and 10 are not co-primes because they are having 2 in common. If you look at 5 can be written as 1 into 5, whereas 10 can be written as 1 into 2 into 5. So they have 5 as a common factor. They have 5 as a common factor. So these two are not co-primes, whereas their simplest form, that is 1 by 2, they don't have any other number other than 1 as common factor. So they will be common factor, they are co-primes. So in this exam, in this kind of problems, we are going to take root 2 in the form of p by q, where p and q are in the simplest form. In the simplest form, that is
P and Q are co-primes, or else you can also mention the HCF of P and Q. HCF and P of P and Q is 1. That means they don't have any other common factor other than 1. 1 is the highest common factor they will be having. So here in this example, we are going to consider square root of 2 is equals to P by Q, where P and Q are co-primes and Q is not equals to 0. Q is not equals to 0. It is necessary to mention this condition whenever you are assuming something which is not given in the question. Now let us proceed. So we know root 2 is equals to P by Q. Now let us apply simple algebraic rules here. I will take this Q to the LHS. So see, root 2 is equals to P by Q is an equation. It has two parts. One is LHS and another one is RHS. So in the LHS we are having root 2 and in the RHS we are having P by Q. Now what I will do? I will take this Q to the LHS. If I take this Q to the LHS, now we are having P divided by Q. When it goes to the LHS, it becomes Q multiplied by 2 is equals to P. This is the basic rules which we learned in solving linear equations. You remember? Whenever an equation will consist of two parts, one is LHS and another one is RHS. Whenever you are transporting any variable or any constant from LHS to RHS or from RHS to LHS, if there is a plus sign in front of it, it will change to a minus sign. If there is a minus sign in front of it, it will change to a plus sign. If there is a multiplication along with it, it will become divided by. If there is a divided by along with it, it will become multiplied. So here in this example we have root 2 is equals to P by Q. P divided by Q. So when I took the Q to the LHS, it became Q multiplied by 2. The division changed to multiplication when I moved it from RHS to LHS. So now we got to know Q root 2 is equals to P. Now we got Q root 2 is equals to P. Now let us proceed further. Now what I will do? I will square on both sides. I will square on both sides. What do you mean by square on both sides? You remember whenever we are solving linear equations, we used to multiply a certain number on both sides or add or subtract a certain number on both sides. Still the equation wasn't getting disturbed. The equation still remained balanced. So this is a rule while solving equation which says if you are applying same operations with same numbers on both sides of the equation will not get disturbed. The equation will still remain balanced. So here we are having LHS Q root 2 is equals to P. I am squaring on both sides. I am doing the same operation, that is squaring on both sides. So the equation will not get disturbed. So initially I had Q root 2 is equals to P. Now I squared in the LHS, I also squared in the RHS. So I am getting Q root 2 square. Q root 2 square means nothing but Q root 2 into Q root 2. Q into Q is Q square. Root 2 into root 2 is 2. It becomes 2Q square. So I can write Q root 2 square is equals to 2Q square. 2Q square. Whereas P square, I will write it as P square itself. I will write it as P square itself. Okay. Now what I will do? I will take this 2 to the LHS. To the RHS, I am sorry. So now I will take this 2 to the RHS. Here we are having 2 multiplied by Q square is equals to P square. When 2 is being multiplied to Q square, if I take this 2 to the RHS, what will become? You remember, whenever you are moving something from LHS to RHS or RHS to LHS, multiplication will become division. Multiplication will become division. So if I move this 2 multiplied by Q to the RHS, it will become divided by here. So when 2 moves to the RHS, here we are left with Q square is equals to P square, and 2 goes that side, it becomes divided by 2 over here. So we are getting Q square divided by Q square is equals to P square divided by 2. Now we look here. Now when you are dividing P square by 2, you are getting Q square. When you are dividing p square by 2, you are getting q square. That means whenever we know p and q both are integers. So when you are dividing p square by 2, you are getting an integer. That means 2 divides p square. You remember we discussed in the last theorem which says if p divides q a square, p also divides a. P also divides a. So here 2, we'll assume 2 be the number p. 2 be the number p, and the number p square is our a square. Here 2 divides p square, then 2 also divides p. Yes or no? So here 2 divides p square, that means 2 also divides p. So we'll get to know. So we got to know that 2 divides p square. 2 divides p square. This implies 2 also divides p. 2 also divides p. So we got to know 2 divides p square, 2 also divides p. That means if you divide the number p by the number q, you will get something. You will get something which is also an integer. I don't know what that integer is, so I'll assume that to be k. So I'll take p divided by 2 to be k. We got to know p square is divisible by 2. So since p square is divisible by 2, even the number p should also be divisible by 2. So we'll take p divided by 2 is equals to k. P divided by 2 is equals to k. So since p divided by 2 is equals to k, now what I will do, I will apply the same basic operations here. I will take 2 to the RHS, the divided by 2 will become multiplied by 2 when it goes to the RHS. I have p is equals to 2 multiplied by the number k. P is equals to 2 multiplied by the number k. Now what I will do? I will do the same operation. I will square it on both sides. I will square it on both sides. Squaring on both sides. I will square on both sides. So initially I had the number p is equals to 2k. I will do squaring over here and I will do squaring over here also. So here I will get p square is equals to 2k square is nothing but 2k multiplied by 2k. That is equals to 2 2s are 4. K into k is k square. That is 4k square. That is 4k square. Now let us come back to our previous assumptions which we have taken. Look at all these equations. Here we have p square is equals to 4k square. Look at all these equations. Does we have p square in any? Yes, here we are having p square. Here p square is equals to 2q square. I will consider this as equation 1. Can you see? So here we are having p square is equals to 2q square. We are having p square is equals to 2q square. So can I substitute this p square by this 2q square? Yes, of course I can. P square is also equals to 4k square. P square is also equals to 2q square. So I can substitute both of them. So what I will do, I will consider this 2q square in place of this p square. So 2q square is equals to 4k square. I will take 2q square is equals to 4k square. Now I will bring this 4 to the LHS. So if I bring this 4 to the LHS, what happens? 2q square. Here 4 multiplied by k square. If the 4 comes to the LHS, it will become 4 divided by 4. That is equals to k square. That is equals to k square. 2q square divided by 4 is equals to k square. So now here we are having 2 1s are 2 2s are. So we are getting q square. Okay, I'll write it down over here. Q square divided by 2 is equals to k square. Q square divided by 2 is equals to k square. So here we are getting to know when you are dividing q square by the number 2, we are getting the number k square, which is also an integer. That means 2 divides q square. 2 divides q square. So if p divides a square, p also divides a. So here 2 divides q square, then 2 also divides q. So can we write 2 divides q square implies 2 also divides q. 2 also divides q. So we can take 2 divides q square, 2 also divides q. Let us look at these two statements now. Here we are getting to know 2 divides p. Here we are getting to know 2 divides q. But what did we assume initially? What did we assume initially? P and Q are co-primes. So I told you co-primes in the sense they will not have any other common factor, any number which divides them other than the number 1. But here we are getting a contradicting statement. 2 divides both P and Q. That means P and Q are not co-primes. But we assumed it to be co-primes initially. That means there is some mistake with our proof. That there is some mistake with what we did here. The mistake is our assumption. The mistake is our assumption. What we assumed is wrong. Okay, na? So here we are going to know that P divides. So we get to know that 2 divides both P and Q. Both P and Q. This implies P and Q are not co-primes, Here is a contradiction. Our assumption was wrong. Here is a contradiction. Our assumption was wrong and root 2 is irrational. And root 2 is irrational. So here you can also include one more statement which says here is a contradiction. Our assumption which we assumed was wrong. Hence root 2 is an irrational number. Thank you. In this belt of topic, you might also get topics such as, questions such as, prove that 2 plus 3 root 2 is irrational. Here, we'll assume that we already know root 2 is irrational and we'll proceed to prove 2 plus 3 root 2 is irrational. Now let us see how we can do that. We'll do the same steps which we followed. Let us assume 2 plus 3 root 2 is rational. Then, if it is a rational number, 2 plus 3 root 2 should be written in the form of P by Q, where P and Q are integers, where P and Q are co-primes. So, in this case also we are going to assume the same. 2 plus 3 root 2 is equals to P by Q. If you are having problem with this P by Q form, you can also write it in the form of A by B, which is not wrong at all. You can also write in the previous example, you can check by writing root 2 is equals to A by B. That is, take it as a home assignment and do it once. Write it in the form of A by B and prove root 2 is irrational once again. You will get clarity then. Now in this example we will take A by B. Let us take 2 plus 3 root 2 is equals to A by B, where A and B are co-primes. So in this case we can consider them as integers itself. We did not take much. Let it be. We will take co-primes because co-primes are also integers. So we will take 2 plus 3 root 2 is equals to A by B. Now we know root 2 is an irrational number. So let us segregate root 2 from the rest of the numbers. So by applying some of the operations which we used to solve equations, linear equations probably. So I want this root to be separated by other numbers. So what I will do, by leaving root 2, I will take all the other numbers to the other side of the equation, to the RHS of the equation. So I have 2 plus 3 root 2 is equals to A by B. I will take 2 to the RHS. It becomes plus 2 over here. When it goes to the RHS, it becomes minus 2. So I have 3 root 2 is equals to A by B. When I take plus 2 to that side, it will become minus 2. So I can write 3 root 2 is equals to a. If you use cross multiplication over here, you can write a by b, that is a by b minus 2 is nothing but 2 by 1. Cross multiplying, we will get a multiplied 1 minus 2 multiplied by b divided by b multiplied by 1, that is a minus 2b divided by b. So I can write 3 root 2 is equals to a minus 2b divided by b. Now I will take, now I got 3 root 2 is equals to a minus 2b by b. I want root 2 separately, so I will send this 3 also to the RHS. Now here we have 3 root 2 in the sense 3 multiplied by root 2. So if I send this 3 to the RHS, the multiplication over here, when it goes to that side, it will become division. So we are left with root 2 here. I will send 3 to that side. So we are left with root 2. Root 2 is equals to a minus 2b divided by b. 3 goes that side, it becomes divided by 3. So we are writing it in the denominator place. So I got root 2 is equals to a minus 2b by 3b. So here we have, you can consider it as integers itself. So because we are going to use the properties of integers over here. So here we know a, b, 2, 3. All the numbers in the RHS are integers. A is an integer, 2 is an integer, b is an integer, 3 is an integer, again b is an integer. That means a minus 2b by 3b should be a rational number because it is in the form of p by q, where p and q are integers. So it should be a rational number. But we already know, in the previous example we have already proved that root 2 is an irrational number. Here we know in the RHS we are having a rational number, whereas in the LHS we are having an irrational number. How can a rational number be equals to irrational number? In the previous videos we have already discussed there is no relationship between rational and irrational numbers. So they are a separate set of numbers. Then how can this rational number, that is a minus 2b by 3b is equals to root 2, be equals to an irrational number? This is where our contradiction arises. So here we are having a contradiction and our assumption which we assumed is also wrong in this case. So let us write those statements over here. So here a minus 2b by 3b is rational. Why is it rational? Since a, 2, b and 3 are integers. Since all these numbers are integers, a minus 2b by 3b is a rational number. But root 2 is irrational. We all know a rational number cannot be equals to an irrational number. Can never be equals to an irrational number because they are not at all any set of any numbers having any relationship between them. So here is a contradiction. What was the contradiction? There is something mistake in our proof. What was the mistake? Our assumption was wrong. Our assumption is wrong. What did we assume? We assumed 2 plus 3 root 2 to be a rational number. So our assumption is wrong and 2 plus 3 root 2 is an irrational number. Hence proved. Now quickly take the example of this and solve the rest of the problems that are appearing on the screen.